Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar is on what's new in 2019, and we'll be covering the subjects of 2.5D, iMachining, iMachining 2D, and as you saw in the invitation, some more features as well. Now, before we get started, I'd just like to remind everybody that in May, we have the SolidCAM World coming up in Orlando. So if you haven't registered yet, please register as soon as you can. And we have a full venue planned for everyone when you get there. And trust me, there's plenty of things that we'll be doing over there. And we hope to see as many of you as possible. So please register as soon as you can. We also are limited in room, so the sooner, the better. Okay, so let's get started with the webinar itself. Okay, let's first start with some of the new options that we have in 2.5D milling. The first option I'd like to talk about is the multi-depth drilling. Now, multi-depth drilling is a new operation which gives you full control of drilling operations at every depth. Now, this is extremely helpful for deep holes and for drilling through cross holes, as you can see in the diagram over here. Now, we also give you at every single depth the control of your spin direction, whether it be counterclockwise or clockwise, or even no spin at all. This is very useful also when you're retracting from deep holes, for example. In addition to that, we also give you at every single depth, we give you the option to control your spin rate and your feed rate. Now, we also have a multi-depth drill pec data. For every single level, every single increment that you go down, you can completely control your pec at every single step down. You can have it as a gradual step down, and we also give you the option of a full retract or a segment start level to go back up to the start of the segment that you started from, or to a user-defined clearance level, where you can define the actual how much you want to actually go up, and then when you go back down to exactly where you want to start from before you start the actual drilling. User-defined pec safety distance, giving you full control of the distance to continue the drilling. Now, let's actually take a look at one of the parts. I'm actually going to show this on two different parts. Now, in this first part, I've already programmed it, and we'll show you exactly what happens inside. Now, what am I doing over here? If we take a look at the actual part, you'll see that we have these holes going through the part itself. And in the middle, we have through holes cutting it on the sides. In other words, we're going through these holes as we're drilling. So we want to have want to have full control so that we don't keep on a regular drilling cycle inside over here. We want to go from here to here rapidly and then continue here, and the same thing down over here. The technology, by the way, you decide on your own exactly how you want to work. So let's actually take a look at the operation itself. If I were to open up the operation, the very start is exactly the same like any other drilling operation. Choosing your geometry, in this particular case, these three holes. Choosing your tool, in this case, a 6mm drill. And the levels. Note the levels is going down 150 millimeters, full diameter. That's the way I planned it. Up until now, up until this point, we're exactly like the drilling operation. Now, when we get into our technology, that's where we have the whole issue of multi-depth drilling. As you can see in this particular case where I've already pre-programmed it, we have all the different levels where I want to go down to and what to do at each level. For example, at 2 millimeters, where I'm starting off at, I'm going with a feed of 2000 with no spin at all. My spin direction is off. Then when I'm going down to minus 33, which is this area over here, just a little past the hole, if I click on this, you'll see that we have a feed rate of 600. Excuse me. And we have a spin rate of 3,500 and we're spinning clockwise. I've turned on my coolant and I have my dwell. Now, if we take a look at my PEC is turned on in this particular case for segment level 2. And I'm starting at 4 millimeters. Then I'm doing a gradual step down with a decrement of every millimeter up until I reach 1 millimeter at the bottom for a minimum. In other words, I'll do 4. My next will be 3, 2, 1, and then it'll stay at 1 because that's my minimum step down. You'll also note that my release distance is set at PEC clearance. So every single time it goes down, it'll only go up 1 millimeter and then go back down to 0.1 millimeters before it continues on its actual drilling. Also, at every single step down, I have a dwell of 2 seconds. If I go to my next step, where I'm going down to 70, which is over here, you'll see I've upped my feed rate to 1,000. Everything here stayed the same, no dwell, and you'll also note there's no PEC here. To the next level, you see I did the exact same thing. All the way to 120, again, this area over here, and the same thing to the very end. By the way, this value 2 and this value minus 153 is given to me by default from the actual levels area. Now, when I retract, I decided I want to go back up to minus 3 millimeters at a faster feed rate. And just to show that I can also do a counterclockwise as I'm going up. Okay, and I do not have a dwell. When I went to 2 millimeters, I actually turned off my spin rate. Let's actually take a look at what happens in the simulation itself, and I'll do this one step at a time. You'll see that the drill is going down. Now it's starting its pecking, and you see it's doing small peck step, but it's not going retracting itself all the time. It's just going up to that 1 millimeter retract. Now, as it goes down to the next hole, you'll see it'll all of a sudden jump to the next hole, and the same thing over there until it goes to the very end. When I get to the end, it'll go up. You'll see now that there's no spin rate because I turned it off. And then it goes to the next hole. And this continues on for every single one of the holes. Now I'm going to load another part over here, which is also for multi-depth. And this part is a good example for deep drilling. As you can see in this part, we have a hole over here, and I'll show you the section view of this. We have 2 holes that are going from the top all the way to the bottom. This is approximately 350 millimeters until we get to the bottom, I believe, if I remember correctly. And this is a 6 millimeter hole. So we have to have a long drill to actually drill all the way down to the bottom, but we want to have full control of our drill. Now, normally the way we start, I've just done it in this particular way. I already created a spot drill for the first operation, a regular drill to go down as deep as I can with a regular drill, And now I'm going to do my multi-depth drilling operation. So I'll go to multi-depth drilling, completely new operation, as you can see on top over there. My geometry, I'll use the geometry I used before, and I'll show that to you. The tool that I will be using will be the 6mm long drill. By the way, I'm sorry, it's 200. The part is 250mm, if I remember correctly now. And if I go into my levels, my drill depth is 250mm, and I want to go full diameter of the part. Now let's go into my technology. And as I mentioned before, you can see my default gives me these two values over here. So for the first one, I want to turn off my dwell. I want to turn off the coolant. So I'll go over here and turn off the coolant. And my spin direction, I'm just going to make it at off. Especially when I'm drilling with a very long drill. As long as I'm outside of the material, I want to keep it off. Because since it's a long drill, I don't want to have it throwing itself all over the place if I start to spin. And I'll have a feed rate. In this particular case, I'll put it at rapid because I'm outside of the part itself. Now, how do I add another step? If I'm over here, I can either right-click and add, or at the very bottom over here, I also have a plus where I can add as well. So I'll just click on add, and I'll put in my next level. My next level, I'd like to go to, say, -5mm. I'm going to keep it at a feed rate of 300, but I'm going to keep my spin direction still at off. People might want to do this because, like I said, as long as I'm outside of the hole, and I'm only going into the hole, I don't want to start my spin rate. Okay? My coolant, I'll keep it off, and no dwell time, and you'll see that my PEC is off over here. Now I'll go down to my next level. My next will be, I'm going to go down to -100. Why -100? Because my previous drill, my regular drill, I went down to 100mm. So I'm going to go down with this up for 100mm at a feed rate. I can change this if I want. I'll say 1,000. Now I'm going to use my my spin. I do not want PEC. Some people may decide that, you know what, while I'm going into a hole that's already drilled, I'm going to go in counterclockwise as not to start make it any wider. That's also possible technology which people may want to use. I do not need dwell. Now the next step over here, I'm just going to go down now to the very bottom. Of course, I can add more steps if I want in the beginning, but I'm just going to make it short. And the PEC, I'm going to have it go down every 6mm, decrement every 0.5mm, up until I reach a minimum of 1mm. I'm also going to change my full retract to a PEC. Clearance level, I have it go back up 1mm and back down to start drilling again to 0.1mm. My dwell, I'm going to have that at 2 seconds. Now, after this, I'm going to add another step, going back up to -5. So now I'm going in the up direction. You can see when it's going up, it's in blue. I may say, you know what, when I'm going up, I want to do it counterclockwise. I'll turn off my dwell, obviously. I can leave my coolant on or off. I'll leave it on for now. Obviously, I do not need pecking in this particular case. And then one more step after this, I'm going to go back up to my safety level. In this particular case, I'm going to turn my spin off. This way, when it leaves the part, there is no spin on the drill, so my drill will not throw itself all over the place. I'll turn off my coolant. I can have my feed rate change over here if I want. I'm just going to leave it the way it is. Save and calculate. Run my simulation. And again, as you can see, now I'm down at 2 millimeters. My spin rate is at 0. Now I'm at -5. My spin rate was still at 0 at this feed rate. Now I'm at -100. We have our feed rate in here, my spin. And now it's going to start the pecking. And as you can see, it's pecking its way all the way down. I'll let it run until it gets to the very bottom. Go a little faster. And then when it finishes this hole, it'll just jump over to the next hole. Goes up and does the same thing over here. So that's as far as the multi-depth drill. Remember now, this is a completely new operation. This is good for every single machine, as this does not use cycles at all. The G code that comes out with this is just a linear G code with G1 and G0. So there are no cycles involved with this drilling cycle, with this drilling operation, the multi-depth drilling. Okay, let's continue now. We've added a new option in our face mill for creating geometry for updated stock boundary. Now, face milling geometry can now be based on the actual updated stock boundary. This will guarantee the full coverage of the stock at any stage of machining. And in a moment, you'll see exactly what we're talking about. In the past, you were only able to do it according to the part, the boundaries, or you had to make a sketch that was bigger than the part and make your boundary on that. Now we can base it exactly on what the actual stock is. Now, in addition to that, in our levels area, we've given the depth a possibility to lock it to this top of the target as well, besides the user-defined. Let's take a look how this works. Let me load the part. And what we have here, we'll see this in a moment, is we have this part over here, and I'd like to do a face mill operation on top of the part. Okay, so what I'm going to do is I'm going to go into my face milling operation. And as you can see, by default now we have stock-based boundary. In this particular case, we don't even define our geometry. This is taken automatically by the updated stock. All I'm going to do right now, I'm just going to add a simple tool right now so we can see exactly what's going on. I'm going to take this 10 millimeter end mill. And the reason why I'm using this end mill is just because I want to show you the tool path and some options that we have later on with it. It's a lot easier to see it with this. My levels, you'll note, by default, we have by top of stock. And our upper level, in this particular case, is 1 millimeter, because that's where the top of my stock is. And the depth is by top of targets. It's going to go down to this over here. If I were to put a value in here, say click on this surface over here, you'll see it'll automatically changes to user-defined. If I put it back to by top of target, it'll go back to that over there. Now, I'm just going to leave my technology right now on hatch and do save and calculate. If we take a look at the toolpath that we have on top over here, and we compare it to our stock, you'll see that it covers the entire stock. Okay, now I'm going to do something else. I've created an operation beforehand, and I'm going to unsuppress this. Now, this particular operation actually machined the outside of the part. So, if I've machined the outside of the part, my stock now is a little different. If you take a look now, my stock has a different shape to it. Okay? So, and you can see I just have to recalculate, and that's exactly what I'm going to do. Let's recalculate this operation. And you can see now that my toolpath is completely different. It's covering exactly where the stock is. So not only do we have full coverage of the actual stock before, if you cut away your stock, it'll actually save you on the actual time that you're doing the face milling without going all the way to the end of the original part boundary. Okay, next. We've added a new option inside our chamfer recognition called Ignore Chamfered Edges in Chamfer Recognition. Now, chamfer recognition can now ignore chamfers already existing at the edge of floors and or the edge of angled walls. If we take a look at the part that we have on the diagram over here, you can see that, for example, this part has sharp edges over here, and these edges already have chamfers. Same thing over here. This wall is at a tapered angle over here. So this also is an area that you may not want to machine. Let's take a look at exactly how this works. But before that, let me mention just one more thing. We've also added inside our chamfer recognition the option of putting in a lower level. This is actually very helpful if you have a tool, a chamfer drill, for example, that is short and that does not reach to the bottom of the part. You can actually limit the distance that you want to go down to. Okay, let's actually load the part. And, sorry, we'll do it from here. Ignore chamfer edges. Okay. Now, as you see, we have this part over here with this face has sharp edges and it has a chamfer over here. Same thing over here as I mentioned before. Now, previously, when you did a part like this, you would always have a problem because when you pick the geometry, and I'll show you this as we go along, the geometry would pick up these edges as well, and you do not necessarily want to work on those. So what people used to do in these particular cases, the only way they were able to work on those was using a simple profile operation, and that would be actually time consuming because you would have to do it for every one of those. What used to happen is as follows. I like to do 3D model protection, it's always good. If I go to my geometry, when I normally clicked on the part itself, you would always get every single edge, including this over here, these over here. And if I were to do a chamfer operation on this, I would actually end up ruining this area over here. Okay? By breaking the burrs on this, which is what I want to do over here, I would actually dig into this area over here, which I do not want to do. And the same thing may be true over here as well. So what can I do now? Let me unselect all. We've added the option of ignore floor wall angles less than, and as default, 90 degrees. So anything that's not a straight wall to floor, such as this area to this area and the chamfer edges, you'll note that the yellow over here has been chosen, but there is no, this has been ignored. This also has been ignored. So if I were to save this now, choose the tool that I'd like to use. I'll use this one over here. Now I go down to my levels. And as I mentioned before, we have the lower level over here. I'm just going to leave it as default. If I want to use this, I can just open it up and put in the value that I want over here. But I'm going to keep it closed for now. I'm just going to put in a chamfer depth of 1 millimeter so we can see this pretty clearly. My technology stayed the same as before. I have my cutting diameter at 1 millimeter. Let's do save and calculate. And if we take a look at the simulation, you can see these edges were machined. These edges were ignored, as well as this edge over here. Now, let's say I did want to put a chamfer on this in any case. Not a problem at all. If I go back to my geometry, I'll edit the geometry that I have over here. I'll unselect, and I'll change this to, say, 70 degrees, which I know this is more than 70 degrees. So anything less than that, it will not choose. So now if I click on the part, you see this time it will include that edge. We'll just accept that and save and calculate. This time, you'll see that the edge will be broken on this as well. So now we have full control of where we want to break our edges, put a chamfer on, and now this is a lot more user-friendly, a lot more useful, and can be used in almost all cases that you need to work in now. Instead of going back and forth into the profile operation and doing the chamfer there. Okay. Now, in 2019, we've also added in our pocket operation the option of using multiple tools. Where in one operation, we can use pocket, we can actually program all our tools that we want to use for that particular pocket. We already have this in iMachining 2D and in iMachining 3D as well, but we've added this now also to our pocket operation. For example, if we take a look at this particular part, and I'm just going to open that part. Okay, I've already created the operation. So I'll just show you exactly what I've done here. If I were to open this up, you'll see that we have here multi-tool. I can also work in regular pocket mode, but in this particular case, I'm working in multi-tool. Now you can see that I have my multiple tools over here, 1 and 2. How do I get that? We'll see that in a moment. My geometry stays the same. The rest of the pocket operation stays the same. If I go to tool, you see we have selecting our tools. My first tool working, just doing rough without finishing on the wall or on the floor itself. And my second tool, T2, will be doing a finish on the wall and on the floor. If I go to my technology, for example, you can see that when this is highlighted, you can see that we have finish on wall and floor not enabled, not checked. If I click to the second tool, you can see exactly the technology that I'm using over here. So we can now, in one operation, create operation. We can create put all our tools into one operation, and the result will be the operations for each tool. Click on any one of them, and it will go back to the operation focused on the tool that you just double-clicked on over there. Next. Now, we've improved our part synchronization with SmartFace. Back in 2017, we added an option for choosing your geometries with the option of what we call SmartFace. We're just clicking on the face, it will automatically create your chain geometries, and will also automatically recognize what's open and what's closed. Now, when we used to do synchronization, we used to do it directly on the actual edges only, on the chain itself. So if you change the dimensions of the part, that would synchronize. However, if you added something like a boss, as you see over here, onto the part, or even change the shape of the edge, this was not necessarily picked up when you did synchronization. But now, when you create a geometry using Smart Face, excuse me, it'll pick up all the changes that are related to that face. So bosses that are added to or deleted from a face are recognized, as well as elements that were added or deleted from the shape will also be recognized when you use the Smart Face geometry. And now, by the way, the Smart Face geometry is the recommended way to create the geometries whenever you can. Let's take a look exactly how this works. And what I'm going to do is I'm going to open up this part over here. And when I open up the part, okay, just a moment. Okay, I'm going to add, say I'm going to add a pocket operation over here. Okay, I'll click on pocket. I'll use the option. And by default, you can see we have Smart Face. Just click on the surface. You can see we have one chain over here. I'll choose any tool that I want to use for this moment. We'll choose this one over here or this one over here. It doesn't really make a difference. And in our technology, I always like using my approach from outside. Save and calculate. And as you can see, my toolpath is out over here. Make one little change over here in the part. Use profile strategy. That's the way I like working. Okay. Save and calculate. And as you can see, we have our toolpath over here going nicely over the part, finishing exactly at the edges. Now, what I'm going to do is I'm going to open the actual part itself in SolidWorks, and I'm going to make some changes. For example, I'm going to add this boss over here and add this to the edges over here. And I'm going to save that. As you can see, we have to synchronize our part. So I'm going to synchronize. And all I'm going to do now is calculate. When I calculate this, you'll see that my toolpath has now completely changed. It goes around the boss. It recognizes now that there's another chain over there. There's a boss over there. And it recognizes that the shape of these, there were elements added on. This is because we now tag the face and we see any changes that affected that face. If I were to take a look inside the operation itself, you'll see that in my geometry, we now have here two chains instead of one chain that we had before. Okay. Next. Last year we added drag and drop, which is extremely powerful option inside SolidCAM. Being able to drag your templates to the part and automatically getting a toolpath. But it wasn't complete. What do I mean by it wasn't complete? There were times where when you create a geometry, let's take, for example, a face mill geometry. Okay? Your face mill, you can have the entire stock, as I showed you before, and sometimes you only want to use it on a specific face or only certain faces. So when you create when you work on geometry in that particular case, instead of using models, you use faces. But when we did drag and drop, it only was able to pick up the entire model, not the faces. So we've added an option when saving a template to include the geometry filters. Okay, let's take a look at how this works. Okay, I'm going to load my next part. And what I'd like to do here is as follows. Wait till the part loads. Okay, now what I've done here is I've already added operations to machine out these areas over here. Okay, and if I do a quick simulate on the entire part, let's do it relatively quick. You can see it's machining out the entire part. But now I have these areas over here, these bosses on the part itself that have material on top of it. And the way I decided that I would like to get rid of that material is by using a regular end mill, but using a face mill one pass on those faces only. Okay? So what I'm going to do is as follows. When I create my geometry, when I create my operation, I'll go into face. We'll go into our second option over here of part base boundary. I'll create a new geometry. And this time I'm going to base it on my faces. Okay? I'm going to define my faces. I'll choose this one, and this one. I'll accept that and separate them. So now I have faces chosen in my geometry filter, as well as I clicked on separate. Those are the filters that will be in here. I'm just going to choose a tool as well. And I'm going to choose a 14 millimeter end mill. And my levels, I'm going to have it at user defined. Okay. It's irrelevant what the value is over here now, but just to show what user defined is, because I want to go down to that level over there. And my technology, I'm going to have it at one pass. Now, I'm not going to save the operation. What I'm going to do now is I'm going to my template. I'm going to save the template, and you see it'll include the geometry filter. Let's give a name to this template. Let's just call it for now webinar on faces. Okay? I'm going to click on OK. I'm not even going to save the operation because I want to show you how we actually use this as well. Okay. I'd like to use now my drag and drop template that I just created. Let me just write in here face so I can actually see all my face templates that I have over here. Here's the one I want. I'm going to take it, drag it to this face. I'm going to hold my control button on my keyboard. So I let go of this now and then click on this face and then on this face. I'm going to let go of my control. Now you can see that my geometry, my toolpath is now created just on those three surfaces because we captured the geometry filters. Okay, next. Let's go into some of the general options that we've we've added into 2019. Just going to go through two of them right now. One of them is that when creating stock by box, you can now create a 3D model of that stock. You used to be able to only create a 3D sketch, but now we can actually create a full model. Now, in addition to everything else, remember how this list always used to be very, very long? And people may say sometimes, you know what? There are things over here that I don't always use, that I don't even need them really, for whatever reason I may decide. And I'd like to have a shorter list because sometimes it can be a little confusing seeing so many things. So we've added an option of customize, where I can take out the options that I don't want to see, and then my list will be shorter. The same thing is true with operations. I can click on any of the operations. I can actually lower the list. You'll see that in a moment when I demonstrate this to you. Okay, so let me load my next part. Okay, if I were to go into my stock, you can see at the very bottom, we've always had add CAD to model, but that would create a 3D sketch. There are sometimes people who like to see actual model around the part. And sometimes they may even use it for whatever reason they may want to. So we've added the option of create 3D model. By clicking on this, it'll actually create a model. And by default, it is actually transparent, as you can see over here. Now, where is this stored? This is stored inside the SolidWorks tree under CAM. You can see this over here. Now, if I want, I can always go over here. If I don't want to have it anymore, I can always suppress it, or I can always delete it even if I don't want to have it. And delete that, and we're back over here. Delete my sketch. I could have deleted that before as well. I'll leave that for now. Okay. In addition to that, when I go to my operations, you see we have a long list over here. If I go to customize, I can actually shorten the list. So if for some reason I don't want to delete all, I can get rid of that. Apply coolant. Anything I don't want to use, okay? I don't like using sorting, whatever. Don't want to use any of these things I don't want to use, I can always get rid of and not use them at all, okay? Now, so when I go to operations now, you can see the list is that much shorter. The same thing is when I go, for example, to add milling. You'll note that my add milling is relatively short already. Why? Because when I went into my customize, I may be a customer that doesn't have all of these options over here. So if I take it off the list, I can uncheck it. I can make myself a shorter list over here as well. So now when I go and right click, add milling operation, the list is much shorter. Okay. Now let's get to iMachining. And this is the last option I'd like to show you inside what's new in 2019. Now, as far as iMachining goes, I'm not going to go now into all of the new options. For that, we're going to have a separate lecture in 2 weeks from now, given by Anthony Calderon. But I'd like to show you some of the features that we have over here, and I'll go over them as well. Now, iMachining we have what we call iMachining feature recognition, where iMachining 2D now makes the definition of your geometry simpler with its new feature recognition technology. Now, there are several ways now to create your geometry, to define your geometry, to select the mode in which you want to work. For example, we have 4 different options. One is by picking faces, feature recognition by faces. Just by picking the faces, you can create your geometry without going into create a chain geometry. The other one is also feature recognition by chains. Sometimes you have a through hole or through pocket where you can't touch a face, so we also have this feature option inside chains as well. Now, another one that's a really, really nice, very powerful option is we have an option for creating a geometry for the outside of the part. So this will automatically take the outside perimeter of the part compared to the stock itself and machine the outside. Now, all of these new recognition modes can detect and define the machinable features based on your selection in combination with your stock and target model data. Now, I'd like to show you, for example, we have one, feature recognition by faces, where you pick the actual faces. You'll have a preview showing you exactly what is going to be machined. And it'll also show you what your upper and lower level is on that face that's being machined. And you can see when you do that, all you do is you see the faces that you pick over here. So the entire pocket features and their parents are automatically recognized. Now, the second option, feature recognition by chains, that's very good when you have a through pocket, as I mentioned before, where you can't pick a face. So you can pick the chain as well instead. And even if you have an open chain, it'll show any of the rest material that may be machined over here. And again, it'll recognize the depth and the areas that just everything that has to be machined. The next one, outside feature recognition, will automatically recognize the stock material and the outside shape of the target. In other words, the perimeter of the target, and it will show you the levels as well. Now, what we also have is our last option, which is the classic way of creating our chain geometries, the way we work today. When using this method, we don't have the recognition options and protection functionality. Let's actually take a look at this as we go along. And I'll go through the questions at the very end. So let's actually do it on this part that we have over here. Okay, if I go into iMachining, I'm just going to show you two of our options over here. Because like I said, we're going to have a full lecture on this in 2 weeks from now with Anthony Calderon. You'll see my first option over here is selecting faces. My third option over here is outside feature recognition. I'd like to use this now. If I were to use that, you'll note you do not even pick a geometry. When I go to choose a tool, and I'm going to use that end mill over here, you'll automatically note that you'll get a preview on your screen showing you exactly what is going to be machined. You can see that right now, as well as the levels, the upper and lower levels that is going to be machined as well. If I go into my levels, you can see that values are automatically over here. Technology, everything else stays the same. When I use my geometry, by the way, you see that we have our stock, target, and fixtures, and all of this is automatically checked over here. I'm just going to do save and calculate. And if we take a look now at our simulation, let me just put it into Solid Verify. You'll see that's machining the outside perimeter of the part. Okay, now I'm going to show you one more feature here. If I go to iMachining 2D, I'd like to now machine specific faces. So I'm going to leave it exactly where it comes. So I'm going to start picking my face. I'm going to pick that face over here. Let me move this to the side. I'll pick that face over here. Note these faces are not even on the same level. That face over there. That one. That one. I'm going to pick all of these faces over here. That's what I want to machine, as well as this face over here. I'll choose my tool. Excuse me. I'll use that end mill that I have over here. And again, you'll see that every single face was recognized. You'll see exactly what's going to be machined. You can see also the different depths of each and every single pocket. If I go into my levels, you'll see we're automatically using the variable levels over here. I'm just going to do save and calculate. And simulate everything that I've done over here. You can see the entire toolpath. You can see now that it's machining exactly where it needs to machine. Now, to finish this off, just to show you one more power of this, I'm going to take this first operation over here that I did the outside, and I'm going to suppress it. Now my material for this has changed. Okay? Right click, I'll just recalculate, and you'll see now that we'll have a different tool pass for those pockets instead of before. Now it's being extended to where the actual stock is. If I were to go into the operation itself, you'll see the preview will show you exactly what is going to be machined. You can see that now being extended to the actual stock. Okay, that's it for now. As I mentioned before, as far as more on iMachining, in our next webinar in 2 weeks, will be given by Anthony Calderon, and he will go into more detail as everything that we've added inside iMachining 2D. Now, the presentation and the parts and a recording of this webinar that we did now will be available later on in the day under the reseller area. So everyone can go to the reseller area and download the parts itself, and I will have the presentation there as well. Okay, so if there's nothing else, I'd like to thank everyone for joining the webinar, and I'd also like to remind everyone again, SolidCAM World 2019 in Orlando is coming up quickly. It's in May. So please, if you haven't registered yet, register now. And I hope to see you all there as well. Okay, take care, everyone. Have a great weekend, and enjoy the program.